back in numerical order. We will now go 4, 5, 6. So unit 4 is congruent triangles. We have a lot that we do with triangles, so this is kind of our last unit was a triangle, so I guess this isn't the start of it. But this is a bulky part of the year. Congruent triangles continue to come back in other units later down the road. So this is a good one for us. Your homework last night was textbook, read, and do some got it questions, and then some practice problems with that. So today we're going to talk about, we're basically going to just reiterate what you learned, or what you read about, and then we're going to talk about what it means to be congruent, and what that tells us about the shapes. Next class is when we get to actually get into the fun stuff of proving triangles congruent. So today is the nitty-gritty, next time is learning the shortcuts. So notice tonight your homework is textbook and worksheet 2. Worksheet 2 is just one side, so back side would be great to do your textbook on that. So this is back to our kind of typical length of unit. We have lesson, quiz, lesson, quiz, review, test. So we're looking at our test being December 10th for you guys. Woo! Okay, so we have to talk about this lovely, wonderful thing that the county makes us do every year. So every year they make us do a quarter 1 e-card assessment. This, for those of you that are not, or for those of you that are new to Fairfax County, we access this through Blackboard. Let me actually go and pull up Blackboard just for those that haven't had to deal with this before. Do they make you do this in the other subjects? History.
Oh, yeah.
Wait, is this from your real name?
Yep. This is required by county that I give it to you.
Is it like 200 questions?
Did you say 200 questions? No, I think it's like 30. Is history like 200 questions?
It's like 6.
What type of grade is it? Is it a quiz grade?
I have to double check. I can't remember. I have to check with other teachers to see what it is.
Okay, maybe if you...
But it's not a test grade.
Okay.
It'd either be a quiz or homework.
Oh, really?
Yeah.
Okay.
It's not a test grade.
So it's not just a bunch, okay.
It's not just a bombshell. Correct, I think. Okay, so for those of you that either haven't done this before or have forgotten, we click on eCart at the top of Blackboard, and then you click here to go to Horizon. And then when you go here, it will appear once it's available to us. So it doesn't open until the 25th. On the 25th, once it opens, I will go ahead and make it available to you. It's not assigned as homework until that night of your test. But if you want to go ahead and start on it once it opens, that's fine, so that you don't have to worry about it. So a couple things with this. Anytime you have work you need to do for a problem, just write the number and put your work on separate paper. You'll turn that in to me, so that'll be part of it, is turning in your work for it. And because this is an assessment, you may not use your notes or anyone else to help you with this. The county wants to know, what do you know at this point in time in the year, okay? But you are allowed to use a calculator. They try to make it similar to SOL questions, and since SOL you get the calculator, I'm going to go ahead and say you guys can have the calculator for this. So access it through Blackboard, do work on separate paper, just you and the eCart, no one else, no Google, no Siri, no people, no intelligence, artificial or human. And you may use a calculator. Okay, questions with that? If you do end up doing it earlier, you can just go and turn in your work early, so you don't have to hold on to your work until that day. That's when it's assigned, but I'll open it as soon as the county opens it to us. Okay. So today, last class you took your test, so today we're going to do our add-ons and then our lesson. But before we do add-ons, I'm going to have you guys check each other's homework real quick, and then my absentees will get you started on your test.
5.
Is it this one?
Yeah. First section.
It was like
Yes, regular operation nowhere.
yeah, that's kind of that's an 8.
Alright, so the pattern you have is 4 out of 10 with initials. And we will start on our add-ons. Phones away, earbuds out, attention up front. Awesome. Okay, so the front side of our page here, this is going to be review from, I don't know, middle school, elementary school, I think probably middle school, and then also what you read about last night. So our first thing that we want to talk about is different types of triangles. So we can talk about triangles in 2 ways, based upon its sides or based upon its angles. So these are words that you've learned back in previous years, but what is one way that I could classify a triangle? How can I name a triangle? A type of triangle. Equilateral. All right. Equilateral. Do you think that's based upon sides or angles? Sides, actually. Equilateral. What is an equilateral triangle?
All sides are equal.
Yeah, good. All sides are equal. Okay. Now, what else do we know about an equilateral triangle? What are the measures of the angles? Yeah, they're all 60 degrees. So technically, an equilateral triangle is also an equiangular triangle, which just simply means all the angles are equal. All right, so equilateral, all of our sides are equal. What's another way to classify a triangle?
Isosceles.
Isosceles. Would that be sides or angles? Sides. Isosceles. Okay. Now our isosceles definition is actually pretty particular. What is an isosceles triangle? So it's actually at least 2 sides are equal. At least 2 sides are equal.
So equilateral triangles.
So an equilateral is an isosceles. So it's kind of similar to that statement, squares are rectangles, but not all rectangles are squares. Equilaterals are isosceles, but not all isosceles are equilaterals. Now when we are naming triangles, we're going to go as specific as possible. So if it does have all the sides are equal, we're going to call it equilateral. But just know it is an isosceles triangle, but more specifically it's an equilateral. Okay, what other types of triangles do I have? Scalene. And what is a scalene triangle? Good, no sides are equal. Awesome. All right, so you guys have nailed all of the ways we can name it based on the sides. What about based on its angles? Acute. What is an acute triangle? How do I know if a triangle is an acute triangle? What about, what's less than 90 degrees? So I like what you're thinking there, but for an acute triangle, we actually don't have hypotenuse. That's only for another type of triangle. But we do need less than 90 degrees. But is it that one angle is less than 90, 2 of them are less than 90, 3 of them are less than 90?
All of them.
Yeah, all of them are less than 90 degrees. Good. So for an acute triangle, For an acute triangle, all the angles are less than 90. Okay. Alright, what else do we have? Base quantities.
Right.
A right triangle. Good. And what makes a right triangle a right triangle?
Both sides of 90 degrees.
When the angle is 90 degrees. Good. Alright, what's our last one? Obtuse. And what makes it an obtuse triangle?
All the angles are more than
Careful.
One of the one.
One angle is more than 90 degrees. Good. Now, I want to talk a little bit more about it based upon angles, but before we do that, what is the sum of the measures of the angles of a triangle?
180.
180. Good. So we talked about that last unit, but here's the specific theorem that states it. So if the angles inside a triangle add to be 180 degrees, it's impossible. So I see that acute, all the angles are less than 90, right? One angle is equal to 90, obtuse, one angle is greater than 90. Is it possible for me to have a triangle that has an acute angle, a right angle, and an obtuse angle? Could I have one of each in a triangle? No, why not? Here.
because a right is 90 degrees, and if you have something that's greater than 90 degrees with an obtuse, it's more than 90.
Good. It would be more than 180. There by itself wouldn't be a triangle, and there wouldn't be left anything left over than 34. Good. Could I have a triangle with two right angles?
I got it right.
No.
Nope. Same reasoning. Two right angles would be 99 and 180. And could I have a triangle with two obtuse angles?
No.
Nope. Again, if we had two obtuse angles, that would immediately be over 180 degrees. All right. Good. Okay. Our third angles theorem. I can't remember if you read about this last night or not. Third angles theorem is a pretty basic one. We don't really use it very often. We don't use it in proofs, but we use it in practice. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Then the third angles are congruent. Which makes sense if I have that this is, again, remember, don't trust the picture, the way it looks, just the information. So this was 120. And if I had another triangle, so it says the angles of one triangle are congruent to angles of another triangle. So I have two triangles with two of their angles congruent. All right. How much has to be left over for my third angle here? 60. How much has to be left over for this third angle? 60. So common sense, but important to see. Okay, so this stuff you probably knew before you read for your homework. Now this next piece was perhaps something new for you, the triangle exterior angle theorem. And so first I want to talk about what it is to have an exterior angle versus an interior angle. So I'm just going to go call this 1, 2, 3, 4. So angle 1 is an exterior angle. And I would say that it is an exterior to angle 3. Meaning that it is, not 3, sorry. I numbered it differently last time. To angle 2. It's an to extend out the side that 2 is on. Okay, so angle 1 is an exterior angle. So then in our theorem it talks about remote interior. Angles 3 and angle 4 are the remote interior angles. Remote interior angles. And again, this is specifically for angle 1. So an exterior angle would basically extend the side of a triangle, and that angle outside of the triangle is our exterior angle. And then when we talk about the remote interior, those would be the two angles that are not adjacent to it, not that they're parallel. So our triangle exterior angle theorem says the measure of each exterior angle of a triangle is equal to the sum of its two remote interior angles. The sum of its two remote interior angles. So before you knew this, in order to find the measure of angle 1, you would first have to find what the measure of angle 2 is. So if we had 3 and 4, we would add that up, subtract 180, because there's 180 degrees in red. We would find measure of angle 2. And then, if I know measure of angle 2, what do I know about angles 1 and 2? They're linear pair, that's just supplementary, so we just subtract that from 180 and get angle 1. Awesome. But now this is a little bit of a faster way of getting it. If you have those remote interior angles, just simply add them together. Immediately you've got that exterior thing. So what we have here is that the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. Questions with that theorem? I loved it. So let's go ahead down to this problem here. And it says find the measure of each angle. Again, there are different ways you can go about it. You can focus on the fact there's 180 degrees in a triangle. You can use your exterior angle theorem. Just to help us emphasize this exterior angle theorem, I want us to go ahead and start off by finding the measure of angle B. Alright, so I can see for this triangle here, angle B is an exterior angle. So the measure of angle B is going to be equal to the sum of what two angles? Here. Okay, so these are the remote interiors that correspond with it. So 42 and 51. So what do we get for the measure of angle B? 93. Awesome. So how can we find angle C? Yeah, it's a linear pair with angle B, so supplementary with this. So what's the measure of angle C going to be? I heard 87 degrees. All right, and then how do I find angle A?
You add 87 and 28 and then subtract.
Good. So we've got, not 87, 93, right?
No, 87 and 28.
87 and 28.
Oh, you're not. Oh, 93.
Good. So we're going to add our angle B and 28. So 93 and 28. 93, 28. 121. Subtract that from 180. And so what do we get for a measure of angle A? What do we get for measure of angle A? Ooh, which one is it? 59? Good, 59. Now, technically, we could have found angle C a different way. If I would have first found angle A, looking at this triangle here, isn't angle C just an exterior angle? So,
to find angle B first.
yes, I had to start off with so if we would have then found A, we could have done C by doing the remote interiors there, 28 and A. So if we would have found A first, we could have just simply added 28 and A together and gotten angle C that way. Also, too, there is this overall triangle. So to find angle A, if for some reason you didn't like this obtuse guy here, you could have added together 28, 42, 51, and subtract that from 80. So again, multiple ways you can go about it. We will be having quite a few pictures where the triangles are next to each other or maybe even overlapping. So you just want to be looking for those different situations, different triangles you can work with. Okay, so we have questions with this first guy here. Alright, I want you guys to go into this next one. Find the measure of each angle. Once you get your answer, check with your shoulder partner. All right, what do we get for our x value?
96.
96, good. You can just start off by adding all of them up, set them equal to 180, or just take these two angles, add them together, get x minus 6 equals 90, because there's only 90 left. Good. But the instruction said find the measure of each angle. So what was the measure of this guy when we took 96 and put it back?
52.
Good. 2 degrees. And how about this guy?
38.
Awesome. Okay, questions with that? Let's take a look at this one below. So it says the ratio of the angle measures of the acute angles in a right triangle is 2 to 3. What are the acute angles? Okay, so it says that we've got a right triangle. So let's draw right triangles here. And the ratio of the angle measures of the acute angles is 2 to 3. Okay, so for our purposes, I'm going to write 2 and 3. Obviously, it's not 2 degrees and 3 degrees. That wouldn't make a triangle. So what they tell us is that the ratio of those is 2 to 3. So whatever these angles are, when I compare them, they simplify down to 2 to 3. Okay, so we've got that component. But we also have the component that we know the angles inside a triangle have to add up to be what? 180. So obviously, 2 degrees and 3 degrees is not going to be correct because that wouldn't add up to be 180 degrees. So what would be some other options? Well, I could double this. So I would have 4 and 6. That would simplify down to 2/3, right? Does that satisfy the 180? No. Okay, well, we could triple it. 6 and 9. Again, simplifies down to 2/3, but does it satisfy the 180? No. So we could just guess and check for who knows how long. Or let's work a little smarter. Essentially what I'm doing here is I know that I can multiply by the same value and it will simplify down to 2/3, right? I could multiply both by 10, 20 degrees and 30 degrees. That's still a ratio of 2/3, isn't it? But would 20 and 30 satisfy 180 degrees? No, so we've got to figure out what it is that we're multiplying by to basically figure out what our overall angles would be. So with that, I'm going to be multiplying by x, so it's like saying 2x to 3x. So I'm just going to call this angle 2x. Yeah, this is a different color. I'm going to call this angle 2x, this angle 3x. That ratio, 2x to 3x, that simplifies down to 2/3, right? And now we can use that to set up an expression. 2x plus 3x plus 90 equals 180. So yes, we could travel down the guess and check road for forever. But what if Mrs. Margraf was so nice and made x a fraction? That wouldn't be so easy to guess and check. Alright, so now that we have it set up this way, it still satisfies that ratio of 2/3, but it allows us to more easily solve for what that x value would be. So we'd have 5x equals 90. What do we get for x? 5 goes in 9 one time. 4 left over. 5 goes into 48 times. So x is 18, right? It's not that 18 is our answer, but 18 is what we're multiplying by to get those angles. So then what would our angles be? What's 2 times 18? 36 degrees. And 3 times 18?
48.
48?
54.
54. You could either just add 18 to that or just subtract that to 90. Good. So that's probably the easiest way rather than just guessing and checking. It would have taken quite a bit to guess and check up to 18. Okay, questions with that? Okay, let's go back up to our classifying. So here it says find the missing angle of each triangle and then classify it 2 different ways. let's just go and make this first column here. Sorry, so this will be the missing angle, right? So angle. Let's call this one our classification based upon the sides, and this one based upon the angles. Okay. So for letter A, what is our missing angle? 60. The triangles just based on the sides. Equilateral. Good. What is it based on the angles? Now keep in mind what we learned last unit are small sides across from our small angle, medium across from medium, large across from large. And we talked about how if I have two angles that are the same, the sides opposite are the same. So for A here, even though they didn't give us the side lengths, they gave us the angles. And since all three angles are the same, all three sides would be the same as well. That's how we can know these well. Okay, I want you guys to go do BCD. Great question. You do it. Talk with your partner, then we'll come back together and talk about it. Oh, interesting. I would perhaps write that down. Your eyes look like it should too. I've seen some like the pages are falling out of my chunks.
Are we gonna do the back?
The third one is not.
Yes, we'll do the back. Oh, man. That did terrible. Pass it that way. Keep passing.
Mikhail, how was your day?
Oh man, that's the best.
Roland, how was your day? How was your day? Pretty good. Mikhail, how was your day? Good.
You know what?
Hey, Roland, how's your day? Hey, cheers at the wall. Yeah, probably.
Okay, let's go ahead and make sure we're all alright with this. What was our angle? 20. Sides? Isosceles. Angles? Obtuse. Alright, what was our problem with C?
Not a triangle.
Yeah, it's not a triangle. 60 and 160 is already over 180. So this is not a triangle.
Which wasn't triangle?
No. Not a triangle. How convenient, there are 3 blanks there. Okay. Can't classify it if it's not a triangle. 50, 70, third angle?
60.
Sides?
Scaling.
Scale and B. And you. Good. Alright, do we have any questions with that? Okay. So we are going to do the backside, but let's just go do a little more practice with this. You have in front of you worksheet 1. Is there one that did not make worksheet 1?
Is your angle measure less than
Okay, so worksheet 1 here, this is just more practice with our different types of triangles, and more specifically our exterior angle theorem. Before we get into this, I want to go ahead and talk about the different parts of an isosceles triangle. So we know that isosceles has at least 2 sides concurrent, but it's going to ask you about like vertex angle, base angle, so I want to make sure we know what those are. So just going to draw an isosceles triangle up top. Yes. Alright, so isosceles triangle, 2 sides are congruent. Those sides that are congruent, we call those legs. So this is a leg, this is a leg. And then that third side we call the base. And then our angles also have names. So the angle that's made up from our two legs, we call that the vertex angle. So this is the vertex angle. And these two angles along your base, we call these base angles. And a little bit of bonus knowledge that we've already talked about, and we're going to talk about this more on our Isosceles base angles theorem day. But in an isosceles triangle, we have two sides congruent. We talked about last unit how the angles opposite would also be the same. So technically, our base angles are the same. I don't know if you actually need it for today, but that is important. Okay, so for this first part here, it says triangle ABC is isosceles. Awesome. Then they have a fun way of telling us which part is the leg and which part is the base. So it says AB is bigger than AC, and AB is bigger than BC. So which ones are the legs?
AC and DC.
AC and BC, good. AB is bigger than both, so that means it can't be congruent to either one. So it means AC and BC must be our legs. Good. Awesome. So then that would mean that this here is my vertex angle. This is my base up here, right? These are my base angles. Okay, they also threw in this fun tidbit that these are parallel. I want you to go ahead and to the front side here. You may do it with your shoulder partner. If you would rather do individually and check with your shoulder partner, that's fine, but start off with those.
Which is side of the triangle is it? Sorry.
All the signs. Like you're just naming them.
All the sides. I don't get the fifth one.
Equals with
Side opposite to angle BC. It's smart if there's no side opposite to BC.
yeah, you're literally like A, B, C, C, A, B, B, C, C, B, C, that's it.
What if you do for 5 and 6?
I'm not there. A, B percent.
Side, oh, maybe.
Okay, so we can say A, but we can't say C because there's three different angles.
Angle
So
opposite
use
to
three
AC.
letters to talk about it. Just like our AC.
Could be A, B,
Yeah.
Can you put the line?
B, C, and B, C.
Wait, if you don't have a line over the angle, that's dimension, right? So like if you write just AC with no line over it.
That means the measure of the segment, yeah.
Are you that?
Wait, when you find everything in the third word one. I saw some. No, you kind of had it in 31, but you're not finding the eight one.
So this is my thing.
You're not even figure out the value to 34.
So which angle is angle BC? Okay, so side opposite we get one across. You got it. Okay, go ahead and check how you do with that top part, just naming the different pieces.
Wait, why is the vertex angle AC and not just angle C?
Great question. Why can't I call this just angle C?
Okay. Because it's on a thingy.
Oh, because there's a thing. Yeah, we've got three different angles here. When you say angle C, I'm going to say, is it this angle? Is it this angle or is it this angle? C is a vertex for three different angles. So we have to use three letters to denote that angle that we're talking about. ACB lets me know that it's this angle here.
Okay.
Okay, do we have questions with any of this naming stuff? Okay, so then for number 8, we're not using the picture up above. Okay, they give us information. It's not necessarily the picture above. Raise your hand if you are still working and haven't had a chance to do number 8 yet. Okay, so I'm going to give you a couple minutes. Go ahead and do number 8. If you've already done number 8, just go ahead and start working on the back side while you're waiting for us to come back together.
Oh,
How is the angle opposite of AC?
The angle opposite of side AC.
Oh, side. Oh, yeah.
Kind of, but not really.
Yeah, 14, 14, and 6. Yeah, it's 14, 14, and 6.
It'll be okay. I just saw scissors in here.
That's
That's what I figured. I like looked over and I just saw you with scissors and I was like, oh, it's all
Volleyball is very fun.
Let me ask you this, what's the thing in
Yeah, I was playing volleyball at church. It was pretty fun. No one was in our group and everybody was scared.
You guys.
Yeah, I was playing there. I didn't really know. It was pretty rough.
Oh, I got X equals 5.
I got X equals 5 and then 14, 14, and 6.
Yeah. Elijah knows. What the hell is 180? Thank you.
I really like it.
All right, for number 8, it says the measures of the legs of isosceles triangle ABC is yada yada, and the perimeter is 34. Something really important is that the angles in a triangle have to be 180. Do the sides of a triangle always have to be 180?
No.
No, my goodness, no. The perimeter of all triangles is not 180 degrees. You'd be surprised how many students every year take the sides and add them up to be 180. No, only the angles have to be 180. But our perimeter is simply our sides added together. Ah, don't look. Okay. So we should have gotten x equals 5 when we set that up. But they wanted to know the measures of our sides there. So they're, our legs were 14 and 14. See there. Okay. So we have questions with number 8. Okay. So let's take a look at the back side. The back side is where we get to actually do a little bit of math here. Now, 1, 2, and 3. How would we go about solving those? Alexa?
1, you would add 2 angles you have and subtract.
Good.
And then 2, you would add them all up and put them equal to 180.
Good.
And divide them.
Find your x.
Yeah.
Good.
And then 3, you already have 90. So you just add them and put them equal to 180, right?
Good. Yeah, so for each of these, we essentially are doing take the angles, add them up to 180. All right, nothing crazy there. Let's go ahead and take a look at something a little more exciting, like number 7. Okay, number 7. How in the world am I supposed to find x when they did not give me this angle right here? Here?
Can you do the partial angle?
Can I have a more specific vertical angles? Good, yeah. So I know by vertical angles, Aaron, that these here are congruent. So let's go ahead and solve for this guy, which will let me know this guy, which will allow me to solve for x. Go ahead and do number 7. Once you solve number 7, I want you to try 8. So I want you to do 7 and 8.
A vertical angle.
I got X.
All right. 90, 100. Did you get
Vertical angles are called.
And then these are both.
Oh, baby, babies. Oh, that's correct.
Oh, wait.
Sorry, you like actually.
That's correct. So now how many degrees are there outside? 180. So 180 minus 70.
I got 25 minutes.
Now we know that the third angle, third triangle. Yeah, that's one angle.
How do you do 850?
Oh, wait.
Yeah, go ahead and give number 8 a try.
So if you do 189, what? And then you find the angles on the other two angles.
Oh. Oh, there's fucking 3 measures of them.
That's number 8. How do you?
Oh, whoa, that's overlap.
So,
It's gonna happen a
We're
lot.
going 65. Overlap. Minus 65. There's so many triangles to solve. Only got the number solved.
oh, okay.
You do 65, 90, and then you find this angle.
Which is like,
Okay, how do you find that?
because this is one big thing.
Oh,
Yeah.
Wait, so let's do 65 is 90.
No, it's not.
No. And then that would make your angle. And then so for that one. And then 50 plus 80 is 100.
Yeah.
You get extra slow.
Alright, let's go take a look at number 9. I mean, sorry, number 7.
50 plus 80 is
So when we add 43 and 57 together, how much was that? 100. I love those types of problems. So how much is my vertical angle here? 80, which makes this 80. So then I had 100 degrees left over. What do we get for x?
50.
Yep.
Okay. Questions with 7 before we take a look at number 8. So take a look at number 8. This would be an example of what I was talking about with those overlapping triangles. So keep in mind, we of course have this triangle here. And we have this triangle here. But when they overlap, it makes this third triangle in here. So they've given us absolutely no information for this little third triangle here, but I can find those different values. If I take a look at my red triangle, how much was this leftover angle here? 25? Now with my blue triangle, how much was this leftover angle? 65, 90, and how much was my leftover here? 50, good. So then how do I find x?
Just adding with the fraction.
Good. 50 plus 25 is 75. 180 minus 75 gives us how much for x? Oops. Okay. Questions with that? We will have overlapping triangles a lot this unit.
Is this like a little weird?
No. This is a very small part. So you'll have overlapping triangles a lot this unit, so just be looking for those. Okay, let's take a look at number 13.
It's a lot. Just like in
Alright, number 13. They've given us that this triangle here is isosceles.
Oh, true.
True that.
And they conveniently filled in for us that these angles are congruent. And then we also have that this is isosceles. Now, they did not necessarily fill in that those base angles are congruent, but again, we know that if the sides are the same, angles opposite are going to be the same. So if that's x, this is also going to be x. If the sides are congruent, the angles opposite are congruent. Okay, so if I've got this as 56 degrees, how much are these base angles here going to be?
Oh, this is
Do some math.
Oh, they're gonna be 60.
I heard 62 twice. Do we agree with 62?
Yes, sir.
Good. Yeah, I agree with 62. Now, just because I have two isosceles triangles with the same length of legs doesn't mean that their base angles are the same. I can have an isosceles triangle same length here. I can take that same length legs, and it's not going to be the same angles. So how do I find then this guy? Edward?
It's like a linear pair with symbols.
Good. Good. So linear pair 62, so they're supplementary. So what is this angle going to be? 118. Okay, 118. All right. I want you guys to go and solve for x now.
That's not helpful.
Yes.
No, it's not. I want my second.
Is this?
Oh, this is x.
Yeah, we can anytime decide these angles are probably the same. From that thing that we learned last time, where it's like small, medium.
What?
36.
36, 36, 36.
I got 31.
Yes.
You get 31. This isn't right.
Alright, what do we get for x? 31. Do we agree with 31? Eliza, are we okay with 31?
Yes.
Do you understand?
Alright, Kara, what's your
I
question?
did 70.
Okay. So in this case, we could not use the third angle theorem because there aren't two other angles.
Correct. We don't have two sets of congruent angles. I only have one angle here, and I don't know what equals here, so we can't use the third angle. Okay. Questions with number 13. Owen and Nikki, are we okay?
Can you do 11?
11? Sure.
Oh, wait, never mind, I get it.
Too bad. We're doing it now. Alright. Let's take a look at number
I'm
11.
not confused. Okay.
We have a nice example here of an exterior angle. Again, you can go back to the fact that this is supplementary, come up with your own expression, and set those equal to 180. Or, we know our exterior angle. Whoa. Try that again, smartboard. Here comes the chart. Alright, we know our exterior angle is equal to the sum of the remote interiors. And these would be our remote interiors. So
I got something too.
103 minus x plus 2x.
Yeah.
That. So let's go and solve. We have 6x minus 7 equals, no, let's do some actual math there. Let's subtract our 103. So we get 6x minus 110 equals x. Yeah. Then I'm going to subtract and add, so 5x equals 110. Am I correct? Am I making any mistakes? All right.
No, very good.
Let's see. 5 goes into 11 2 times with 1 left over. 5 goes into 10.
This is right here was right. Oh yeah.
Okay. Questions with that?
Too.
No, it's just.
Okay, let's go ahead and come back to our notes and take a look at the back side.
Wait, I'm sorry. Margaret, do you also use transversals when you are doing your taxes? I did.
Do you do taxes?
You know, I did do my own taxes. I got.
Where the heck is this?
You have to do an accountant.
I did not get this
Yeah,
paper.
something like that.
Oh, I got the paper.
Some person in Ohio does it.
I commit tax fraud.
Okay. Congruent polygons. So on the back side here, now we're going into the, our unit is on congruent triangles, not just kind of segue into what that means to be congruent. Now, this unit focuses specifically on congruent triangles, but we're going to talk about what it means in general for any polygon to be congruent, any set of polygons to be congruent. All right, so congruent polygons are polygons. Who would have thought? Polygons that have congruent sides. Sorry, I should say corresponding sides here. So polygons that have corresponding sides congruent and corresponding angles congruent. And corresponding angles congruent. Polygons that have corresponding sides congruent and corresponding angles congruent.
The same shape, same size.
Same shape, same size. Now, when we write out a congruency statement, so let's just say that we have, I don't know, quadrilateral, we'll see the triangles here. So let's say that we have triangle, ABC and XYZ is already used. DEF is congruent to triangle GHI. Sounds good. When we have that two polygons are congruent, then their corresponding angles are congruent, corresponding sides congruent. What that means is that if I take a look here, side DE is going to be congruent to what side over here? GH. Likewise, side EF is congruent to what side over here? HI. And side DF is congruent to what side over here? GI. So not only are that's what I mean by corresponding. We can pull that from our statement. You could draw a picture and mark it. But also we have our angles. So if I were to say angle D, what is that congruent to? Which angle? G. Assuming that these pictures are individual, we don't do some three letters. All right, what about angle E? What is that congruent to? H. And angle F is congruent to angle I. Now, since it's a triangle, we have three sets of sides congruent, three sets of angles congruent. If it was a quadrilateral, you'd have four sets of each. If it was a pentagon, 5 sets of each. So when we write out our congruency statement, we need to make sure we have corresponding vertices match up. So it's important the order of the letters. Okay. So let's just go take a look at these pictures. Now these pictures don't have any markings on it. We're just going to write out our statement based upon observation. For your homework, you're going to have pictures with actual markings on them. No, thankfully. We're gonna do that, but just by marking it on the picture. Okay, so we will have these 6 pieces of information for every single picture, but for sake of preventing arthritis, we're just going to put the markings on the picture rather than writing out those 6 things every time. So looking at our first picture here, again, we're making the statement based upon observation. The triangle ABC looks like it's congruent to triangle XYZ. Now, again, what we have to have is all 6 sets are congruent in order for us to say that the triangles are congruent. Or if they tell us that triangles are congruent, then we can say these 6 pieces. Next class, instead of having to prove all 6 pieces before we can say they're congruent, we're going to talk about 5 different shortcuts, how we can more quickly know if they're congruent. So when the triangles are congruent here, then I know that side AB is congruent to side XY. side BC and YZ, side AC and X and Z. Awesome. We also have our angles. Angle A matches up with X. Angle B matches up with Y. And angle C matches up with Z. So if I ask you to write a congruency statement, that's this guy here. So just going right next to this is what we call a congruency statement. Saying that two things are congruent. So let's just go ahead and fill in our congruency statements here. What do you guys think for this next one? RTQ is congruent to what?
LKM.
LKM. Again, the order of the letters matters because I need to have the R and L match up, T and K match up, Q and N. All right, how about our next one? THR.
XYW.
I feel like this one's perhaps not as easy to see.
It's XYW.
XYW. XYW. Good. So again, what we have is that these different, once we know these triangles are congruent, I can say those 3 sets of corresponding sides and 3 sets of corresponding angles are congruent. Okay. Now, right now, if we were to do a proof, we would have to first show all 6 pieces were congruent, and then I could say, by definition of congruent triangles, the triangles are congruent. Likewise, if I have that my 2 sets of triangles are congruent, then I can know that any of those 6 pieces are congruent. This is extremely helpful for us when we do proofs later on this unit. Once I know triangles are congruent, then I can say corresponding parts of congruent triangles are congruent, which is simply saying, hey, I've got congruent triangles. If I have congruent triangles, I know that their pieces are congruent. Now we use an acronym to shorten this so you don't have to write out corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC is something that we'll be using a lot in our proofs, but it is important that you make the distinction. This can only be used after you have congruent triangles. It can only be used.
We have to be told it's congruent.
Either we're told it's congruent or we first prove it's congruent, and then I can say the pieces are congruent. It can only be used after we have congruent triangles. You can't say that HR and YW are congruent if we don't know that the triangles are congruent. So we have to first show the triangles are congruent, and then I can say any piece of those are congruent. Questions with that? Okay, so go back to worksheet 1.
Are we gonna finish this small graph?
Yes. No. This is like the very, very beginning basic part of it. So right now you're pretty much just going to be stating which pieces are congruent. You only have to list all 6 pieces when it specifically asks to list all the congruent parts of each triangles. Yeah. That'll happen like 3 times this whole unit. We're going to do more with it. Okay, so let's just go and do some more practice with our actual like math stuff for today. I want you guys to challenge yourselves. Number 14. You knew that one was coming. 12. I think I want 10 and 6. $14, $12, $10, and 6.
Excuse me.
You finish it?
Well,
Yay!
I haven't been for a while.
Caden. Oh, I see.
Yeah.
I see how she messed up.
14 isn't even fun. 133. 133.
Thank you.
Can I do some double set?
Can you what?
Can I do some double set?
Then just work up. Guys, if you finish. Oh, look at you working on it. You can start working on your textbook. Guess what your assignment sheet tells you. What your assignments are. So guys, 14, 12, 10, 6, if you finish those before we get to go over them, just come work on the other ones. Should be fun.
Did you get equals
Did you finish up your work that was due today yet?
14?
Okay, so don't start working on that. And actually, we don't use calculators in here, so it's, I mean, we're just going to get the practice of the calculation.
58 plus 47.
So just going to
It's Marvin's house ballpark. You don't even need
it's not, but it's something different, because they give you markings, so you have to know something about the triangle to know that. Yeah. Here, I circled it.
One 48, 30.
I'm confused on how people mess up.
okay.
So for this angle, I got 58 because it's fine.
Yeah, no.
68? Okay, that's right. So
Wait,
then it would be
this bar got-
115, right? Okay, that's right. And then 6 plus 4 is 11, 115, 65.
Yeah, for that angle that's not even inside of a triangle.
Obviously, I didn't even have to write it. I just wrote it.
Yeah, 60. Just add it on.
That's good thinking. It's not going to help you out.
Oh yeah, I got 30.
So we have overlap.
I didn't write one of these questions.
So did I find that angle versus the triangle?
You already did all of them?
No, yeah.
Yeah.
And then I could find that angle.
40 minus 17. 30 minus 5 is 35.
14, right? Yes.
It's nice.
I think 1, 2, 3, 4, 5, 6, 7, 8.
I didn't ask you what it was.
Where's that?
So I finished it off because
163 divided by
when we were done with like what's wrong.
Okay.
Sam, for 60 you get 27. For 60 you get 27.
Yeah, 27.
10, 32. 12, 120. 14, 65. Right. What?
I got X equals 27.
I got some, yeah.
What did you get for the angle?
You don't need to. You just need to solve for X. All you're doing is solving for X.
You get for 10.
I got 32. 32. 10 X equals
No, you guys 32. Could you do 90?
I'm not.
Because you're already on the outside. So you did 90 from the you add all up.
That's too tired. And that was in my mind. I added the
This training is
180. Sam, for 90 to get 111.
You add negative 17 plus negative 5. Negative 40 plus negative
12.
11.
112.
I probably took
I
11.
got 112.
Mother Yucca. What is 180 minus 44?
Mother what?
132, right?
No.
136.
Yeah.
136 divided by 2 is 69.
Isn't that a bit?
What's 36?
That's what I know, yeah.
Fuck you. Honestly, I think we done.
If it was 100.
And for number 3, did you get 29?
Giant hole.
No, I got 87.
Wait, how do you do 11 again?
No, it's 29.
Oh, okay. I saw that.
Alright, never mind.
Dude, Dylan's in my PE.
I was just like,
He's in my PE, yeah. I don't know why you came.
have you seen it?
No, but I know it's here. Because people have seen it. You're accurate.
I was opening
I can't hear you.
I got a 91 overall. I didn't know I could sell that.
You know you can look it up. Like, go to the auction. Or go to the auction. Find players. Go to auctions. Go to post auction, and then
Okay, go ahead and bring your attention back up
you
front.
what?
Luke, my dear, what are you doing?
Casey.
I know it's only the notes. No big deal. Alright, attention back up front, please. Let's make sure that we are okay with these. So number 6, we got X was 27. Do we have questions with that? Just a age-old case of added up and set equal to 180.
Because it's...
Alright, and then number 10, they gave us 90 degrees here. So, you can either do your linear pair with this, or just 90. Do your linear pair, subtract that. And then we've got 12 was 120. 14 was 65. Do we have any questions on those? Okay. And then for those of you that did the rest of them, I'm just going to go and display the answers up here so you can double check those.
You are welcome.
Do we have any questions on those top 6 there? Alright, I'm just going to go and bring up the rest of them in case you want to check those.
Oh my god, the shell so I can't hear out of
You could have made
Two cases.
Alright, is there anyone that did not get worksheet 2? Now your homework tonight is worksheet 2 and textbook. And conveniently, the backside of worksheet 2 is blank. So your textbook there. Phineas, did you get a worksheet 2? Phineas.
No,
We're good.
Yeah, like all.